Hi all, my name is Letty, working with Dr. العنزي as research assistant. Now I will give a brief description about the work brine management from desalination plants for salt production utilizing high current density electrodialysis evaporator hybrid system, a case study in Kuwait. As you all know, desalination is considered as the main contributor to reduce water stress in almost all parts of the world. In Kuwait, there are 9 desalination plants located along the Gulf Coast, 7 of which operate with MSF technology and the rest operate with RO technology. Despite the type of desalination plant, disposal of rigid brine from desalination plants into the seawater is a crucial environmental issue. Rigid brine contains high salinity, high temperature and residual chemicals from pre-treatment processes which cause potential damage to the marine and underground habitat. The objective of this study is to demonstrate improvised solution for the rejection of desalination effluent from Kuwait's desalination plant. So in this study, we investigated the viability of utilizing an ED evaporated hybrid system in treating synthetic brine water having a concentration equal to actual rigid brine from MSF plants in Kuwait. So in the experiment, a pilot scale ED equipment PCSL P05 consisting of an electrodialyser unit fitted with 25 cell pairs of monovalent selective ion exchange membrane and 3 tanks dilute, concentrate and electrolyte for treating synthetic rigid brine of concentration 65 to 68,000 ppm to produce low ppm water and coarse salt were carried out. Now coming to the methodology, in order to carry out the experiment, a concentrated brine series ED method with internal recirculation of concentrate effluent was done. The experiments were carried out in 3 current densities 300, 400 and 500 and 2 flow rates 400 and 450 liter per hour. Now moving to the results part, we could observe that as the current density and feed flow rate increased, the operation time to reach the maximum concentration was reduced. This was due to the enhancement of the mass transfer of ions across the ED membranes with high current densities. Another observation that was made is that at a higher flow rate, the current efficiency of the process was higher. This is due to the reduction in the system resistance. As you can see in this graph, when the feed concentration increased through 7 runs from 65 to 175,000 ppm, the current efficiency decreased. This is due to the reduction of the electrical resistance of the solution. Now moving to the performance of the monovalent selective membranes, almost similar concentration of sodium ions were analyzed in the concentrate tank after the first stage of desalination. That means the membranes were efficient in selectively transporting monovalent ions. A water recovery rate of 65 to 70% was maintained in all the experiments with a concentration of less than 3000 ppm in the dilute tank, which can later be used for agriculture or can be discharged directly to the sea. In the energy consumption graph, we can observe that at a higher flow rate, operation has consumed less energy due to the low residence time of the feed inside the ED unit than that of the lower flow rate. Now coming to some of the challenges we encountered during the experiment. After finishing the experiment, the membrane stack was dismantled and few membranes were taken for an inside investigation. On the right hand side you can see the SEM images of the fouled up membranes. SEM EDX results were generated to characterize the fouling substance. We could find that most of the accumulated ions were divalent ions such as magnesium and calcium. This continuous accumulation of ions on the end cation exchange membrane led to form cracks on the surface of the end membrane and thus resulted in the rise of electrolyte level in the electrolyte tank. In the next study, we will be using a modified electrodialyser unit. Now coming to the conclusion part. We can conclude from the experimental study that application of ED is an effective method to obtain salt from MSF plants rigid brine, especially in Kuwait, where the electricity cost is low. We could publish this work recently in a Q1 journal, Desalination, with an impact factor of 7.098. Now Dr. Badar will quickly show you the PCCell P05ED unit that we have used in the lab and also the fouled up membrane from the electrodialyzer after the experiment.
The ED pilot plant, which is a big one, it's about $100, maybe $30,000. And this is what we use actually to convert the brine into edible or wet salt. Edible means on top. The one we just opened was on top here. So we removed it for maintenance to change whatever fouled up membranes and put them back. The electricity really goes into the system. And then this is the top part of the membrane stack. This is ED membrane. Yeah. Even though the fact that the other one, the one before it was not, the third one was fouled up. Is fouled up again with divalent ions. And ions like calcium and magnesium.